Imagine this. You're sitting in a car, not moving. Suddenly, the driver hits the accelerator and your body pushes back into the seat. Why does that happen? Why does your body know the car moved even before you think about it? Welcome to the 3 rules that control every movement in the universe. This is the Learning Studio, where we explain the world with clarity and curiosity. Let's crack Newton's laws like you're 5: fast, simple, and unforgettable. First, imagine a big heavy stone and a small toy car. Push both with your finger. The toy car moves easily, the stone barely moves. Why? Because objects have a natural stubbornness. They don't like changing what they're already doing. This leads to Newton's first law: inertia. If something is resting, it wants to stay resting. If something is moving, it wants to keep moving. That's why a football won't roll unless you kick it. A car won't stop unless brakes act on it. Your body jerks backward when the car speeds up and forward when it suddenly stops. Your body was just following the first law. Newton's second law, the real workhorse. This law tells you exactly how motion changes. The idea is brutally simple. If you push harder, it accelerates more. If it's heavier, it accelerates less. That's why lifting a small bag is easy, and lifting a big suitcase feels like fighting physics. The formula is famous. Force equals mass acceleration. This is the equation behind cars speeding up, trucks slowing down, rockets launching. Even your simple act of throwing a ball. More push equals more acceleration. More mass equals more resistance. Newton's third law, action and reaction. Every action has an equal and opposite reaction. This law explains everything you see but don't notice. You push the wall pushes back on you. You jump, the ground pushes you up. A rocket pushes gas down, rocket goes up. A gun fires the bullet forward, gun pushes back into your shoulder. Motion is always a two-way conversation. Now here's something to think about. If every push has an opposite push, how do rockets move in the vacuum of space where there's nothing to push against? We'll answer that in the next lesson. This is the Learning Studio. Subscribe if you want the entire physics series explained in this simple, sharp way.